name's Dean Belfield, probably better known to you on Twitter as Breaking to Prog. As you probably know if you follow me, one of my hobbies is collecting retro computers. I've got a small collection now, which includes an Acorn Electron. I've got a ZX81 and a Sinclair Spectrum. The Spectrum, if you'll follow my webpage, I repaired over Christmas. Unfortunately, it's developed another fault, so the board at the moment, the bottom 16K, seems to have voltage issues, which I'll be repairing at some point over the next couple of weeks whilst I'm in isolation. One of the other things I did over Christmas is build a Sinclair Spectrum Harlequin Clone. It's actually in this case at the moment. It's the case I borrowed from the broken 48K Spectrum. Basically this is a Spectrum 128K clone, a toast rack clone, based upon a book by Chris Smith. So they've reversed engineered the ULA and implemented it as discrete logic chips. So the kit comes with a couple of bags of discrete components. These seem to contain individually wrapped and labelled components. Good. There's a bag of chips, not literally a bag of chips, it's actually a bag of silicon chips. So it looks like we have a Z80. That's an AY chip. I hazard a guess that those two are RAM chips here. Zoom in a little bit closer. And then we've got all these discrete logic chips, so many of these will be replacing the function of the ULA. Some instructions. I've already read these instructions, they're very good. The kit's aimed at folk who are comfortable with a soldering iron, but may not have assembled a complete board before. Let's have a look at that. Zoom in a little bit. Turn it the right way, it helps. There we go. Trick with soldering is to take your time. So I've got a solder station. The temperature on this is currently set to 350 degrees. I'm using a fine-ish conical tip. My eyesight's not the best. You can see what I'm doing. I heat up the pad, the component pin through it, making sure I'm touching the pad and the component leg. Hold it on for 2 or 3 seconds. And then hopefully solder will flow. Maybe my soldering iron needs a bit of tinning here at this point. So I'll tin. Just give it a wipe in my steel wool thing. Let's try that again. So heat the component. There we go. Hold it on for a couple of seconds. And there we go. A perfect joint. And repeat. So a couple of seconds. There we go. I've got my power supply set up. Just rotate that around a little bit to 9 volts. Plugged into this connector. I've got the polarity correct. We're plugged into composite video. Plugged into the television. There, I plug it in after all this time. Here goes. Okay. Well, I must admit that's a bit disappointing, but given the number of components I've just soldered on, not unexpected. So the next thing I need to do is check all of the solder connections. Okay, so all the chips are in the right way. All the solder connections look okay. I mean, this is the work here, the back. You can see there's an awful lot of solder connections. In fact, I've gone through almost an entire 0.025 kilogram packet of solder here, working on the basic assumption that either the instructions are wrong or I soldered this dip switch in upside down. So before they were all off, that should be 0. And according to the dip switch, I should now be selecting bank 7. But if I solder it upside down,
or the instructions wrong. Maybe that is selecting bank 0. Let's try it. Hey! Check it out. I was right. Fantastic. So I'm selecting ROM 1. 128. There you go. Let's move this fella out of the way. There you go. 128, working absolutely fine.
So as you can see, it's quite a challenging project. There's quite a few components to put down on the board there, but it's not beyond the wit of someone with a reasonable soldering iron and basic soldering skills, and the end results are well worth it. So one of the other things that I like doing is programming retro computers. I'm currently working through 6502 on the Electron, a language that I've used in the past on the Nintendo Entertainment System, but not really played around with much. I'm also writing a vertical scroll on the Spectrum using some advanced techniques that I wish I'd have known or used in the day, including using the stack to blit data around quickly and chasing the raster so that I can achieve a 25 frames per second smooth scroll with lots of sprites on screen and minimal to no flicker. This is a brief introduction to some of the stuff that I do. If you're interested in this, please feel free to follow me on my YouTube channel. I'm on Twitter at BreakIntoProg, and you can also find me on my blog, breakintoprogram.co.uk. Thank you very much for watching.